In this slide, we will discuss Avogadro's hypothesis and arrive at the concept of mole in chemistry. The concept of mole in chemistry is very important as it centers uh, the most fundamental understanding how molecules and atoms react in finite proportions. And let's try to understand what all does this mean. The Avogadro's hypothesis can be stated in the following way. Equal volumes of gases contain equal numbers of particles at constant pressure and temperature. What does this mean? This implies simply that if I have a certain volume, V1, then the number of particles in that is N1, and the volume is proportional to the number of particles at constant temperature and pressure. And so in this, V1 is the gas volume, N1 is the number of gas particles. If I have another sample that has a volume V2 and has number of particles N2, then it is mandatory that V1 over V2 equals to N1 over N2. How did I get this? Well, simply dividing the first equation, V1 equals to K times N1, with a second equation that I can write, V2 equals to K times N2. Then I can divide the first equation with the second one and thereby cancel the value of K, which is a constant in both equations. So V1 by V2 equals to N1 by N2. So coming back to the Avogadro's hypothesis, what it says is that if V1 equals to V2, then N1 must equal to N2. And that is the case from the mathematical expression that we have written about. Though this leads to an important concept in chemistry. That is, if I were to choose a particular amount of gas sample and define the pressure and temperature, and then its volume is fixed, then it should have certain number of particles in it. That number of particles can be defined in a convenient way as equal to a mole number. That is, if we say that n be the number that we are interested in, let's say Avogadro's number, and the volume is the molar volume, meaning that is the volume occupied by 1 mole of a gas, then we can define what is a mole. So if I were to have, let's say, 12 grams of pure carbon, then the number of atoms present in that sample by definition at standard temperature and pressure equals to Avogadro number. So in a similar fashion, if you were to look at gases, one could say that 1 mole of hydrogen, for example, standard temperature and pressure will have Avogadro number of molecules of hydrogen. And so this, by definition, describes the number of particles present in a sample. Now, why is this so important? It's because chemical reactions occur in finite proportions. For example, one atom of, let's say, hydrogen reacts with one atom of hydrogen to form one molecule of H2. So if you are interested in calculating how many grams of hydrogen atoms will react with another, how many grams of hydrogen atoms to give how many grams of hydrogen gas, one needs to define a convenient unit. And this unit is a mole, not grams. That's because the atomic masses of different elements are different. Therefore, 2 grams of hydrogen molecules contain Avogadro number of particles, whereas 32 grams of oxygen contains the same number of particles, that is 1 mole, at standard temperature and pressure. And therefore, the mass is of a sample and the number of particles are related to each other through their molecular weights or atomic weights. So if I want to write a stoichiometric chemical equation, and we define then 1 mole of a substance react with certain other number of moles of the second reagent to produce certain moles numbers of products, not in grams. And so the concept of mole is important and needs to be thought out more carefully. Now, this has been introduced to you many times before, and therefore, I'm not going to spend too much more time than this.